Good day everyone, this is the General Physics Performance Task by Group 7. Introduction. This is our first digital portfolio task in General Physics, a collaborative work on errors, measurements, and linear regression, in which we will be solving a specific scenario and showing you a way to get the right answer. And this is our scenario 2. Understanding weather impact on agriculture. A local farmer has noticed that temperature fluctuations are affecting the pressure in his greenhouse, which in turn impacts the growth of his crops. He is asked for help in understanding how temperature changes affect the air pressure inside the greenhouse. A farmer from a nearby town is struggling with maintaining the right conditions in his greenhouse due to varying temperatures. Your group analysis of the relationship between temperature and pressure can help him optimize the environment for his crops, potentially improving yields. And this is the task. Calculate the mean, variance, and standard deviation for the pressure. Use linear regression to determine the relationship between temperature and pressure. Interpret the physical meaning of the slope and intercept in the context of the ideal gas law. So this is our data set. First, we will look for our pressure. Our given KPIs will be X. You will see that we have 10 of them that would be our N. After that, each KPI should be subtracted by our mean, which would 114.35, and then after that, the answer that you have acquired from subtracting your X, you square it by itself. Once you have completed that, you find the sum of the squared X minus mean and keep that aside. Now, in a different table, our X now would be the temperature, while our Y would be the pressure. With the formula xy, multiply your x with the corresponding y. Find the sum of all the xy, and keep that aside. Now, last but not least, you square your x, find the sum of and keep that aside. Now that we have everything we need, we will find the variance. And to do that, you simply have to divide the sum of x minus mean squared over the number of amount of gas in moles that is given, which is 10. For the standard deviation, same thing with the variance, but now you have to square root. To find our y, we have the formula n times sum of xy minus sum of x times sum of y over n times sum of x squared minus sum of x squared plus sum of y minus m times sum of x over n. To break it down, we do the first equation. We will label it as m. The sum of xy minus sum of x, sum of y over n, sum of x squared minus sum of x squared, the answer to this would be our m. After we have found our m, we can continue to the second part of the full equation, which would be b equals 101.5727273. After finding the m and b, you sum them up and that would be our y. Here is the y in 3 significant figures, and here it is with 5 significant figures. And this is our graphing of the scatter plot. What is the gas law? Ideal gas law is a formula that explains how gases behave. It states PV equals nRT, where P equals pressure of the gas, V equals volume space the gas occupies, and amount equals amount of a gas in moles, R equals a constant, T equals temperature in Kelvin. There are three key points: pressure and temperature relationship, what to expect, summary. Pressure and temperature relationship: when the volume is constant, increasing the temperature raises the pressure. For example, hotter air pushes more against the walls of a greenhouse, increasing the pressure. Second, increasing temperature equals increasing pressure. As the temperature goes up, temperature goes up and pressure goes also goes up, showing a direct relationship. And lastly, understanding the higher temperatures lead to higher pressure helps farmers manage greenhouse conditions effectively, promoting better crop growth. Farmers to consumers. How can we, as consumers, support farmers in making all the important decisions presented in this lesson? Conclusion. There are several theories about the relationship between temperature and pressure. First, Boyle's law relates pressure and volume, while Charles' law states that volume is proportional to temperature and at constant pressure. Avogadro's law connects volume and the amount of gas. This law can be combined into ideal gas law, which describes how pressure, volume, temperature, and the amount of gas are related. In a greenhouse, higher temperature increase pressure, which is crucial for farmers. If temperatures rise too much, the pressure can harm crops. Therefore, managing temperature through ventilation and monitoring is essential for creating a stable environment for plant growth. And that's all. Do you have any other question? Don't hesitate to ask for our help, and thank you.